Hey guys, so this is a series where I attempt to solve LeetCode problems, and I'm just essentially picking random problems. Since these are the first few videos, I'm attempting to do easy problems to start off with, and once we get used to the easy problems, we'll move up to harder problems. So let's go ahead, jump in, and get started with this one. And again, I haven't seen these problems before. I have no idea what's coming, so don't expect these to be tutorials. Expect these to be how it actually is when you're trying to solve one, and this is what you can probably expect of yourself. Okay, so you're given a string J representing the types of stones that are jewels, and S representing the stones that you have. Okay, each character in S is the type of stone you have. You want to know how many of the stones you have are also jewels. The letter in J are guaranteed. The letters in J are guaranteed distinct, and all characters in J and S are letters. Letters are case sensitive, so A is considered a different type of stone from A. Okay. So in our first example, we have J equals little a and large a, and then S we have little a, large a, and then a lot of lowercase b's. So there's what, three distinct types of stones here. Uh, okay, you were given a string J representing all. This is so hard because normally when I'm solving these problems myself, I'm trying to think about it, but I'm trying to very clearly articulate everything that's going through my head. So instead of actually clearly understanding everything, I'm just vocalizing things, which actually makes it hard to understand. But let me try again. Uh, so S represents the stones that you have. The letters in J are guaranteed to be distinct, and all characters in J and S are letters. You want to know how many stones you have are also jewels. So you want to see how many of these are characters which are in here. Okay, that's really simple. And since this is a lowercase c and these are uppercase c's, they don't match at all. Okay, cool. So this shouldn't be too hard. So essentially what we want to do for this is we're going to want a list of jewels, right? So let me explain this more clearly, what I'm going to do before I do it to make it a little more obvious. So I want to take this J, which is a, I'm going to split it up so it's just like little a and then larger a. And then I'm either going to create like a set or a hash or something along those lines. And then after I do that, I'm going to put each of these in. And then I'm going to break up this array into individual characters, iterate through all of the characters in that array, and see if they're contained within this set. If they are in this set, then I'll increment my counter by 1. If they're not in this set, then I will not do that. So this should be a relatively simple problem, so let's go ahead and get started. Let jewels equals j dot split there. Okay, so that should give us a list of the jewels. So now we want to make that a set. So we can actually just say let jewels equals new set, and then just pass this in, and it'll automatically create a set for us, which is pretty nice. So now we're going to want to do a similar thing with S, which is our gem bag, right? So our stones. Let stones equals S dot split there. So now we want to iterate through the stones with a simple for loop. And then after we do that, we want to say if jewels dot has stones I, and then we're going to want to have a counter, let count equals 0, and then we're simply going to increment that counter, and then we're going to go ahead and return the count at the end of the function. So we can go ahead and run that code real quick. That test case appears to work. So let's do the other one, z and then zz, and see if this fails as we would expect, or not fail, but output 0. 0, cool, test cases work. Let's go ahead and submit the solution, and it looks like it passed. So cool. Pretty simple problem. We could optimize this a little bit. We don't actually have to create a stones array whatsoever. We could just track the index and then iterate through the strings, so we're using less memory. So this is one potential optimization that we could do. Outside of this, the code seems relatively straightforward. So yeah, that's about it for this one.